Whoa, okay. Alright, we're good. I can't talk. How's it going, everybody? We're live. Oh, it's been well, it hasn't been that long. Dude, whoops, I forgot to open the, how do I forget this every single time? Oh, man. What was I about to say? I forget. Alright. Look at that, you get to see a little smiley face cube thing. I don't know what this is, but it's a quick texture I made in like 30 seconds. Oh man. Hey. Hi Dr. Cake. Hi Geek Gazer. How's it going? Dude, the old codebase for Scuffed Minecraft was so bad. What's up, Fantasy the Commander? And also Vox. So I will explain. You should keep it as a debug block. True. We should make everything smiley faces. I should totally do that. I'm gonna copy this little dude from this project and paste it into Scuffed Minecraft. Shoot. When's the next vid? This is probably going to be the stream that turns into the next video. Well, this and others, I guess. Yeah. Alright, I think Twitch is probably working, but nobody's watching it, so that's fine. That's weird. Did the stream notifications work? It looks like the Twitch one did, but not the YouTube one. I don't know why. Alright, whatever. I don't really care. I'm trying to test out stuff. Okay. Anyway, so let me go ahead and explain. What's up, MX Ritzdev? How's it going? Put this comment in the next video. It'll probably be there. So my new plan or vision for the game engine, right, is I have in here. I have the core package. Wait, hold on. I gotta find it. Here we go. I have like the core engine module, and then basically it's gonna be like the most modular game engine ever. Okay, it's gonna be like, well, not ever maybe, but at least it'll be a very modular game engine. That way I hopefully won't rewrite it every few months because this way I can just rewrite whatever is bad about it, and I don't have to like restructure the entire game engine from the ground up. So that's kind of part of why I'm rewriting it. The other reason is just simply because it sucks and the code base is awful and everything. So now, basically, like I have the core engine that'll include basically the core project structure, and then we'll have like 3D rendering module, 2D rendering module, and I might end up making like a voxel module for voxel worlds. But after thinking about it, I like don't really know how to do that, or I should say like I don't know how to make it usable for other people because it's going to be specifically made for Scuffed Minecraft. I don't know. Streamlabs is a lot easier than OBS. Yeah, I know it's like easier to set up, but I've like in the past anyway, it's been it performed worse. Like it had worse quality output and more lag, so that's why I don't use it. But Restream is pretty easy to use, so it's alright. Except Twitch is dumb with its bitrate limitations. So I have to like record and stream separately. It's kind of annoying. Oh, because of Twitch. But anyway, so let's get started. So because of this, oh, and by the way, like Scuffed Minecraft is like a learning project. I'm not trying to make necessarily like a one-to-one clone of Minecraft. I'm just trying to learn how to do C++ and like voxel games and everything. I am gonna make my own voxel game someday. It'll be great. I don't understand, but it's interesting. Fair enough. Alright, so and here's the other cool thing, right? I'm kind of proud of this. There are all of the dependencies are like pulled. Oh no, what did I just do? Are like pulled in. So none of these things, like we have glad, glfw, glm, I'm GUI. We have all these things, right? None of them are like copied and pasted into the project from somewhere. They're all done using fetch content in CMake, which is cool. I'm happy with that. And the project works on Linux, which is also cool. So, but right now, of course, Scuffed Minecraft looks like this. Hold on, I gotta wait for it to build. It looks like this. We got like our FPS counter here, and that's it, the blank screen. So that's we have nothing, so we're starting from square one, quite literally, because we got to build a square. All right, so to do this, we are going to create square. Wait, I gotta move my chair down. Oh. That hurt. Hi, that one dev. Hi, Zine. All right, create square. Okay, here we go. We gotta create a square. So to do this, I made a lovely little ooh, what? Oh, that's why. Okay, I made like a rendering vertex array object abstraction here. So like, look at how easy it is to render a cube. Ready? We create a vertex array object. Wait, we gotta actually do it this way, I guess. VAO. Ooh, that's not where we want to put it. And then in here we can set VAO to a new vertex array object. VAO. Oh, we gotta actually write the vertices though. So we're gonna need to do, I don't know, float vertices. Is there such thing as too much modularity? Perhaps. I don't know. To be fair, this game engine is mostly just like for my own projects. It's just I figured I'd make it public in case anybody else wants to use it, but it's probably not that good, so I wouldn't recommend it. Plus, it'll be good on my portfolio. Alright, 0.0f, 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 I guess, and then we'll make one 1.0. Wait, why am I doing it this way? We're gonna do it like this, actually. And then 0.5f, negative 0.5f. Whoa. And then we can do negative 0.5f, 0.5f, and the top corner. I don't know why I'm like narrating it like that. So this is just going to be the position, and then we'll add a texture soon. But we'll do it this way for now. And then we can get our indices. Unsigned int indices is equal to 0 to 1, 1, 2, 3. Alright, so now MVAO, and then we can buffer the vertex data. This is going to be size of vertices, and then we have our vertices, and then we can also buffer the element data, and this will be an element buffer attrib type uint32 num elements. We got 6, and we can just pass indices, and that's it. That's, wait, actually, is it? I don't think that is it. No, it's not. So then we set an attribute pointer, 0, attribute size is 3, the attribute type, vertex buffer attrib type, and it's going to be a float 32, normalized, false, hold on a second, vertex size, 3 times size of float, and then we do that. Okay. No, we don't need that. Perfect. All right, so that's it. Repetition. I tried using the engine, but I didn't know how to add it as a dependency. Do I have it in the instructions? I might not. I know there's a project template. If you want, there's a branch for it in Voxel engine. That's kind of how I did it. or how like I have it set up. However, the main branch is still the old Willow Vox. How does one know everything by the top of his head? Yeah, pretty much just memorization. I forget all this kind of stuff all the time. Like every time I create a new project where I'm doing OpenGL commands, the first thing I always do is rendering abstraction, and so I never actually remember how to do it. Do you think you'll try DirectX 12? Maybe. Right now, like, I'm trying to keep it simple and platform independent, so I don't have to write like tons of different stuff. I like how I still have things copied from documentation on I'm GUI. Alright. So this is it. And what this does is basically if you go to learn OpenGL and you go to like creating a triangle, hello triangle, like it's everything that this thing says to do, but you don't have to do all this stuff manually. So this vertex array object just automatically creates a vertex buffer and an element buffer, and you can just buffer the data with this. It automatically manages the lifetimes and everything. It's beautiful. And so this is all you have to do, and then you can just render it in here doing, I guess we can do, wait, why do I have the FPS count in here? Oh, I guess just, oh, whatever. I'll make like a render UI. And I'll put this in here. And then my render stuff will be nice and clean. Okay, and then in here we can just do mvao.draw. And that's about it. Now it's probably not going to work because I don't have any shaders yet. Well, it actually did work. Look at that. We get a black box. It's just a little hard to see because it's a dark gray background. But here's the cool thing, right? We can create a shader in here. Shaders. And then we can do like chunk shader dot vert, and we can do a chunk shader dot frag. And then in here, it's relatively simple. Neat. Yep. Yeah, I have like, so this was something that I just did this morning actually, was I made it so you can set like the app name and the resolution in here. And these are just like extern variables, which is cool. I didn't know you could do that. Well, I kind of knew, but I wasn't very familiar with it. Kind of learned that. Hi, Lil Fresh. All right, I don't remember the shaders off the top of my head, so we're gonna pull that up. Okay, so version, I'm gonna use 450 core. Layout location is equal to 0, and then in vec3 a pause. Okay, so that's the position. And then we can just do void main gl position is equal to vec4 a pause 1.0. Okay, so that's all we really need for the vertex shader. For the fragment shader, version 450 core, out vec4 frag color, and then we can just do void main frag color is equal to vec4, and we'll do like I guess like a light blue. Whoops, 0.5, 0.5, 1.0. What? Why are you having a stroke? Wait, huh? Wait, what is, oh, because I'm an idiot. It's a vec4. Okay. Okay, so anyway, now that we have that, hey the Zach, how's it going? I'm doing alright. Can you please make a tutorial about that? You know, I have wanted to make tutorials in the past, but I'm so bad at it and I don't enjoy it in the slightest, so I feel like it would be really horrible. It would be like a terrible tutorial. Alright, let's load in a shader. So this is pretty easy as well. If you do, I'm actually going to make this like a unique pointer, so I don't have to do this manually. Vertex array object, and then we can just set this to make unique. Okay, We can make another unique pointer for a shader. Actually, this is going to be a shared pointer. And we're just going to call it shader. We're actually going to call it chunk shader. Alright, so then in here, we can get in a reference to our asset manager. AM is equal to asset manager dot get instance. And then we can just do get asset, type shader, and put in the name, which is chunk shader. And that's it. That's literally what, wait, actually I need to set shader. Chunk shader. That's it. That's all you need to do. And then that loads in the shader. And then we can bind the shader when we go to render. Dot, oh, bind. And then we can run it. Look at that. Shader loaded in successfully. We get a blue square now. So, I'm also making an OpenGL render. Recently added textures. Nice. Textures are annoying. How do you store the assets? Alright, so here's how I store the assets. Okay. So in here, wait, where is it? No, not that. Build, include, source, okay. Assets. So we have the asset manager. So this contains like an asset loader and an asset provider. So the asset provider is essentially just like a, you know, it has like a generic sort of class here, and then this is what you get like for each asset type. Basically you create one of these asset providers, and it just has like, you know, an unordered map that contains them all, as well as a string ID, so you can just do like get and you get the ID, and that's just the name of the asset. And then so that all this really does is when you call get asset from asset manager, you specify the type. It then checks to see if it has one of the asset providers for that type, and if it doesn't, it creates an asset provider, puts it in here. This is using type index, which is nice. That just makes it so that you can get like a different, you know, a different asset provider for each type of like class or whatever of object. And then it'll get the provider, it'll create it if it doesn't exist, and it'll call get asset on the asset provider. And this just, you know, gets it from the unordered map if it exists. And if it doesn't exist, then it calls an asset loader for that type. And this is kind of the unique thing, because it needs a unique asset loader for each type of asset. And so I have inside a shader, for example, shader contains an instance of this. You have to write each of these manually. So we have the asset loader for the shader, which loads the shader from the file. And in this case, it looks at this assets shaders folder and pulls out a .vert and a .frag file and combines them together. This is the part that I kind of want to change a little bit, because I don't really know how I feel about it just having to be in this shaders folder. I kind of wish that you could put it wherever, but I don't really know how to do that, because I also don't want to make it so you have to load in every single asset at like the start of the program, because then you have all this stuff loaded in that doesn't need to be loaded in. But you know, I gotta figure it out still, but it was just something I made pretty quickly, so. But I'm pretty happy with it. It's generic, so that any module of the engine, anybody who's developing a module, can easily add a different type of asset. It's not all hard-coded in. Third time's a charm, yep. Modern C++ is so crazy. It took classes in college for it like 15 years ago, but haven't used it much. In the last 10 or so years, it's changed so much. Yeah, I know. It's pretty cool, though. They added a lot of different stuff. I'm pretty happy with... Oh, I like the things like type index is really cool. I think that's a newer thing. It's pretty cool. Thanks. They just have a map of resource like shader. That's what I used to do. That's what the old Willavox does that, and a couple of my other projects do that, where it's just like everything's hard coded in. So I had like get shader, load shader, and you had to like load all of your shaders at the start of the program. And this time around I wanted to change that, so that's what I came up with. Okay, so moving on. So now we have shaders loading in, and that's literally all it is just get asset. So let's go ahead and add this texture. So we can do, let's see here. We can do another shared pointer with a texture. Whoops. Test texture. Well, we'll just call it chunk texture, whatever. Chunk texture. Okay, so then chunk texture will be right here. Load in a texture, and this one is currently called test because it's just my little cube thingy. And then what we can do is, first of all, bind this, and we're gonna bind it to texture text 0, and then inside of these we're gonna first of all need another one of the, or another in whatever vertex attribute for text chord, and then we can do, hold on, I have to look at my other thing because I don't remember this very well. Out text chord, and then we can do text chord is equal to a text chord. All right, and then that's going to be inside of here, so we're just passing in the texture coordinates into the fragment shader. Dur Phillips, subscriber prime, subscriber for 4 months. That's awesome. Thank you. What extension do you use for GLSL? I have no idea. I guess it's this one, GLSL lint, or this one, or this one. I don't know. Just one of these three. Happy coding. Thank you. Alright, in vec2 text chord, uniform, sampler to t text. Okay, and then here we can use texture instead of a color and just pass in that. Perfect. So that is our shader done for now with textures. Do you plan on adding multiplayer? Yes, I do. And that's in one of my test projects I did multiplayer, so I already know how to do it too. I don't know when I'm gonna do that though. Here. Does this mean there's gonna be a new video? Yes. Okay, so by the way, this might end up being like, I'm so close to 10,000 subscribers, it might end up being like a 10,000 sub special. But I don't even know. I kind of want to release something before then, but I'm so close to it that I'm probably not gonna get it done in time. Alright. Literally less than 10 away. Okay, so now that we have the texture, it should just work now, I think. I would love to make tutorials, but I'm really bad at making tutorials. I feel like I would do a horrible job. Oh, I forgot to actually add the attributes to this, huh? 0.0, 0.0, 1.0, 0.0, 0, 1, and whoops, 1, 1. Perfect. Alright, and then we just need to add this attribute. Whoops, 5, 5, 2 times size of float. Whoa, what did I do? Okay. That should be good. Alright, now it should work. Yeah, I gotta set that. Okay, now it's not working at all. Oh, because I set it to the same index. Duh. Oh boy. Alright, I definitely messed this up. Hold on a second. What did I do? Why does it look like that? It's just like 6 lines. Hold on a second. Oh, I know why. Because I set the stride wrong. There we go. Yeah, I was supposed to do 3 times size of float. I messed that up. Alright, so now it's really stretched. Very wonky. So let's fix that now. Or that, well, I should say fix it. That would be your camera. So let's do a camera. Why not? Let's make a camera. Alright, here we go. Ready? So we're gonna do unique pointer camera. Camera. And then with this camera, we can just create that real quick. STD make unique. And that's really it. And then we can just, oh, we need to add the variables in here. We need uniform map for model, uniform map for view, and uniform map for proj. And then we can do that times view times model, and that is 3D. Now our shader should be done for a while. Is it YouTube compression making the texture flicker like that? Probably. I don't see any flickering on my end, so it might be the stream. Alright, so then the camera, every single frame we just need to get the FO, or not the FOV, sorry, the projection matrix and the view matrix. And set that to like auto proj and auto view. And then inside of the shader, what is it? Set map for proj to proj and view to view, and then we need a model matrix yet. So we do what am I doing here? GLM map for model, and then wait, how do I do this? Hold on a second. I'm not very good at this whole 3D thing. I forgot how much setup there is to do this part. We just need model is equal to GLM map for 1.0, and then GLM translate. And then we can set the model matrix in here. And then theoretically, now it should be like a square. Yeah, look at that. Okay, so now it's perfectly square and everything. It's good stuff. 10 more subs to 10K. Someone needs to sub. Yeah, I know, right? It's so close. But yes, I do have the camera set up already, which is neat. Well, I have like a camera abstraction. Pretty good stuff. Will you use an ECS or an ECS? Yes. I want to make it myself for now anyway, and I might switch to something like Entity later. But I like doing things myself just so I can learn how it works and everything. So that's gonna be a future video. I'm gonna have like polls for voting for future ideas or future like videos that we're gonna do, and one of those pretty early on is gonna be the entity component system. But for right now, I don't. Well, yeah, gotta build it up, you know. All right, so now we have the camera. We have, what's the next step? I forget. Oh, we need to. Okay, so next up, I want to make it so that we can control the camera because we're not gonna be able to see a cube otherwise. All right. So in here, what we're gonna do. Oh, watch this. Hold on. This is beautiful. We have an input class where we can do get key, key W. Beautiful. dot position dot or plus equal to m camera dot front times, we'll make like a speed variable, and times delta time. Alright, and then down here we can do float speed is equal to like 5.0, I guess. Alright, so we have this beautiful input class which just gets, you know, it has all this input stuff, and then I have key abstraction so it's not using GLFW keys. And then we have we also have delta time calculations that happen automatically. So that makes life very easy. Alright, let's see here. So then we can do minus. We can copy and paste this again for like A and D. I do study computer science, specifically software development is the name of my major. Alright, so then we'll make like E up. There's some really loud truck outside. I don't know what's going on. Whoops, no, we don't. Dude, why is it so loud? Brother, what are they doing out there? I don't know what they're doing outside. Can you hear that? If statement key inputs. Classic. Yes. Shouldn't the camera have more functions instead of setting the position manually? Yeah. It when I have the ECS, the camera's gonna work a little differently. I'm also gonna do like actual transforms instead of putting position inside of the camera class, because that's pretty bad. That whole implementation is definitely subpar, but you know, it's just like a temporary thing anyway. Alright, so then next up we can do looking around. So like camera dot, yeah, and then we just have direction in here. Dot y, shoot, what was it? How did I do this? It was wait, I have it in here somewhere. So we'll do like direction dot x plus equal to, oh, and then we do like auto, so your mouse move is equal to input get mouse delta. That gets the change in position. That's also gonna need to be changed, but again, temporary code, some of it. Sensitivity. I'm surprised I spelled that right first try. I'm really bad at typing. Alright, and then dot y minus equal to mouse move dot y. And then we can do, I'm just gonna copy and paste this code. I don't feel like writing a camera class for 2 hours. Okay. And then tell you what, I'm actually just gonna copy this so that we don't have to sit here and write this. This was my camera implementation for my test project. Yeah, except it doesn't work. Hold on a second. M mouse disabled is equal to, well, actually we want it to equal to true by default. And then of course every instance of camera is currently wrong because I named it M camera. Okay. I'd indicate how different is your code, but shouldn't the mouse move that access be switched? Maybe. I don't know. I think I might have done it weirdly when I was making it. But then look at this. We can do at the beginning of the runtime in start. We can do input dot set mouse mode disabled, and now when we start it, you can't see the mouse anymore, and it'll work like a camera. Whee! Look at that. So now we got our camera. If I press escape to show the mouse, it doesn't do anything anymore. It's perfect. I can also slow down and speed up using the scroll wheel. And now we can see our cube in all of its glory in 3D space. So it doesn't have a back. Alright. Well, this isn't a cube, it's a square, my bad. So let's go ahead and make it a cube. Exit status 0. Ooh. I had a camera before blocks, but then when added chunks, realized it was flipped. Nice. Controller support is something I want to do in the future, but I don't know how to do it. It was for the code. Oh, got it. Yeah. Yeah, so this is just code from my test project, so that's about it. Okay, so now we have to make a cube. Now, cubes are complicated because they have more faces than a square. And I always struggle to visualize the cube in my head. Cuz like it's all complicated, so we need like the north cube or the north face. I don't even know what face this is. What is this face? This is going to be like the north face, I think. And then yes, I am using GLFW. And it's going to be like something like that. And then we get the south face. North face. Am I gonna get copyrighted for writing north face? That'd be hilarious, actually. Texture chords. And then in here, we need to like flip it. So it would be like this. This is the south face. But then we would need to flip this, right? Because it's like boom, 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 boom. Everything needs to be clockwise. And it needs to not be weirdly inverted. So we do like that kind of thing. And then we get to, I don't know why VS Code is so bad, but whatever. The east face, right? The east face is going to be, everything's switching up now. Boom, boom. So this way, so this one is going to be on like this side or whatever. And then it needs to go, what, like negative to positive or whatever? Like that maybe? And then we get the west face, which is going to be on the opposite side. So we set all these to the x to negative, because negative is west, and then we reverse these. And then we do the up face. It's hard to visualize this in my head, so that's why I'm like barely commentating about, or like incoherently commentating, I should say, about what I'm trying to do. So then the up face is gonna be like up. That would be positive, and then it would be like negative, negative, positive, positive, I think. And we have the down face, and that would be like the opposite. Except, I think this needs to be changed. Why did it do this? No, stop. Alright, and then for the indices, we basically need to do 4, 6, 5, 5, 6, 7, 8, 10, 9, 9, 10, 11, 12, 14, 13, 13, 14, 15, 16, 18, 17, 17, 18, 19, 1, 2, 3, 4, 5, 20, 22, 21, 21, 22, 23. Alright, and this is what, 36 indices or whatever. 1, 2, 3, 4, 5, 6. 6 times 6 is 36. Yeah. Okay, so that should be good. Let's see if that worked. Oh boy, not quite. So some of these faces are right. 2 of them are, oh, all of these are reversed. Okay, only 2 of the faces are right. Perfect. Okay, so let's start with the up face. Wait, so what am I doing wrong? So like if we look at a cube, right? Boom, boom, oh. Boom, 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 boom. Ooh boy, this is a rough one. This needs to go boom, 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 right? Like 1, 2, 3, 4. for my stuff to be correct, which means let me zoom into this. Okay, which means this is like what, negative x and then positive x, and this, wait, shoot, wait, hold on a second. Did I reverse the because that's what I did, right? I did negative, positive. Did I reverse these? South is this side, right? This is south, and the north face is on the other side, I think. And then, so north or south is positive, so I think I reversed these. See, what did I say? I get mixed up on this all the time. I'm bad at 3D. Make it wireframe. That's actually true. Yeah, winding orders is kind of the problem. Will I be considered dumb if I'm trying to make it in Python? Nope. Just understand that Python is very inefficient. Yeah. But it could be a good learning experience, though. I mean, I did this in Unity before I did it in C++, so... You gotta, you know, take it step by step sometimes. Alright, so now I mixed up east and west. Those are reversed now. North is positive Z? I don't think so. North is negative Z, right? This is like... Yeah, east is positive. Yeah, so like... 3D rendering stuff is weird because like east is positive and up is positive, but then north is negative. And it's so annoying. Alright, so I must have mixed these up. Alright, let's try that now. Yeah, it depends on if you do Y up or Z up. I feel like games typically do Y up. It's just easier or more consistent to keep it that way. Alright, there we go. Now it's working. So we got... Yep, that looks correct. That looks like how I want it to look. Got the north face. All of the smiley faces are upright. Perfect. Alright, there we go. We got our cube. We got our happy cube. Alright. So now that we have a cube, we need to make a chunk, a voxel chunk. So let's get started on that. First of all, what I want to do, I'm tired of putting everything in main, so I'm gonna make an includes folder and a source folder. I'm gonna move main into here, and then in here we can do chunk.h, and then in here we'll do our chunk.cpp. Alright, pragma once, and we can do namespace, what did I call it? Oh, I guess Scuffed Minecraft. And then class chunk. Perfect. Alright, and we're also gonna want like a chunk data class, eh? Chunk data. This is just going to be a header only one. Pragma once, and there's going to be a struct. So namespace scuffed Minecraft struct chunk data, and temporarily this is just going to be essentially just like a boolean, and then we'll put like a const express chunk size. Oh, whoops. In chunk size is equal to, we'll just make it 4 for right now so that we can test it easily. Use a texture with an F. Yeah, that's a good idea. I do know, like, my smiley face texture is off-center. Or the smiley face is off-center. And it's more to the left. So, it works for me. Quaternions win? Oh, man, I'm not excited for that one. Alright, so we'll just make, like, bool voxels, and we'll just make it chunk size times chunk size. How did I turn numlock off by accident? I don't know. And then we can do, I guess we can say chunk data. Wait, we don't need to do that. Okay, never mind. We'll just do that. Okay, perfect. Up and down UVs, one of them is flipped. Alright, chunk data. So this just gets the voxels. So then in here we can make a chunk with a shared pointer. And I'm gonna need to include that. Okay, shared pointer of chunk data. Shoot. I need to set my includes folder. Add, wait, what is it? Target, include directories, Scuffed Minecraft, private, include. This needs to be source.main, and then we need source.chunk. I'll organize it later. It'll be fine. Alright, so then inside of chunk, yeah, so we just get chunk data. Boop. Alright, so then in here we just store like a reference to chunk data. Why did it do this? I don't know, whatever. Shared pointer. Chunk data. Alright, perfect. And then in here we can also include a render. And yeah, that's good for now. So in here then we can do include chunk.h namespace Scuffed Minecraft, and then we can just copy and paste these things. Chunk and render. And then we can say chunk data dot. Wait, what am I doing? Alright, this is where we need to actually generate like the chunk. So, I guess we're gonna need to store more than this, huh? Because we're gonna need the actual voxel data, which is gonna be a vector. Or wait, no, we don't need to do that. But we need to do is create a unique pointer of a vertex array object. MVAO. I am doing cubic chunks in this one. I love cubic chunks. It makes me happy. So that's what we're doing. I guess we're gonna need like a shared pointer for a shader as well. Chunk shader. And a chunk texture. Which will eventually be put into a different file, but yeah, it'll be fine. Yeah, these will eventually be held in Chunk Manager instead. Maybe. I don't know. We'll see. Alright, so chunk shader, chunk texture, blah, blah, blah. I can't talk. So then in here we can say, I'm going to create the chunk. First of all, we can set these variables based on the asset manager. I'm also just going to do using namespace willowvox to make life easier. Auto am is equal to asset manager dot get instance equal to am dot get asset shader. It's just gonna get the chunk shader, and then for the chunk texture, it's just gonna get chunk texture. So that's the first thing. So that then when we render it, we can just set VAO to whatever we need to set it to. Or sorry, no, we just need to render it. We need to bind the chunk shader and the chunk texture, and then draw. So that's it for rendering. We get all these at the very beginning, and then we can create like a private, or we don't even really need it to be private. We can just say void generate mesh. Put that in here. Chunk generate mesh, and then in here we can generate the mesh at the very beginning. Perfect. I'm gonna rename this to chunk texture, even though it's a smiley face cube. Cubic chunks are better. It kind of depends on what you're going for, because it does make some things slower if you don't need like a big or a tall world. But if you're having like thousands of blocks in height, like if you want really big caves, then yeah, the cubic chunks are going to be better. But they're definitely situational. Yeah, it's if you can get away with 2D chunks instead of 3D chunks, or by 2D I just mean like the entire height is in one chunk, then it's definitely better. But for my game that I want to make eventually, I want taller worlds, and it would just kill the performance to not have cubic chunks. And so I figured I might as well do cubic chunks now. Alright, so generate mesh. What are we gonna do for this? Generate mesh. Okay, so this is where we need to make our cube. First of all, we're gonna make a vector of a vertex. We're also gonna put like a struct called chunk vertex. Well, why did I do that? I don't know. Okay. Why are we making chunks? Can't I get a region around the player and update every block in the region? So that would kill performance, because every single, like, you would have absolutely gigantic, or a huge, like, every time you had to re-render it, like, every time you updated a block, broke a block, whatever, then you would have to, like, completely reload the entire world. And so that's kind of why chunks are better, because then you can just reload one chunk instead of the entire world. Much better for performance. Also makes it easier to render and to load things in. All of that. Alright, chunk vertex. We're gonna do GLM vec3 position. We'll just go let pause. We'll do a GLM vec2 text pause. And that's it for right now. And then in here we can store just a chunk vertex, vertices, and an std vector of ints called indices. And then for right now, we'll just, add essentially these. So we're just going to create a cube. Vertices is equal to, or vertices dot pushback -0.5f. I wonder if I can easily perfect. Oh, and that's going to require that. There we go. And then we can just do, let's see. So like this is the north face, right? This is positive. No, I guess this is the south face. Yeah, this is the south face. I wrote north face here. It's not even correct. Whoops. Boom. 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 And that's still positive. 1, 1, 1, 1. Okay, so that should create a north face. Oh, except for indices. Dot pushback 0. And we're actually going to create like a int index count is equal to 0. And then we can just write index count plus this. 0, 2, 1, 1, 2, 3. And then we can do index count plus equal to 6. And then we can kind of just do this sort of thing for that. Chunk size, I'm probably going to do 32 by 32 by 32. And I am making a new Willowvox. So this is technically using Willowvox, but it's using a new version of it. Chunk vertex compression. I don't even know what that is, so maybe. Hi, Christ and Pure. Sorry, the chat messages seem to be disappearing really quickly, and I'm not even reading them before they disappear off the screen, but that's right. Alright, so now we'll just test it with just this face for right now. So we can do mvao is equal to std make unique vertex array object. Let's see if I I guess that works maybe. So then we buffer the vertex data. Do we need to do this? I kind of feel like we could just do whatever, it doesn't matter. I mean, it does matter, but okay, size of vertices, dot data. And then we can do the data. Perfect. mvao buffer element data. If I don't have to remake it every time if I'm just buffering new data, right? I don't think so. I think if I just do it this way, it might be better, because then I could just, you know, whoops, element attrib type in 32, num elements would be indices dot size, and we'll just do indices dot data. Perfect. All right, and then at the very beginning is when we can do our attribute pointers. Set attribute pointer. I love LODs. Yeah, I know. Level of details. Details something I definitely want to do, but I don't really know how to do it. We'll see. You shouldn't buffer the vertex data and generate mesh if you're gonna do multi-threading. Yeah, I know that. I am gonna move it eventually. But I figured might as well just keep it simple for right now. And then we can move it to a render thread when we get that far. But yeah, you're right. I do need to change that. All right, so set attribute pointer 0, 3, vertex better. I also want to make this better. I don't really like this whole system, but I also have to work within, like, it's, like, I don't like having to write vertex buffer attrib type float 32 for this. It's just kind of weird, but it's whatever. False vertex size. Wait, how do I feel like you can do this a lot easier if you just do size of like vertex. I don't remember how to do it. Whatever, it's fine. It's size of float. We'll just do 3 times size of float. I know there's a way to do this better, but like there's like an offset of vertex, or sorry, chunk vertex, and then you can just type in pause, and I think that's how you do that. And then we can just put in Whoops. 2 text pause quaternions. It's offset of, I think. Can you do a size of attribute? I don't think you can. Oh well. Quats are not really that bad. Yeah, I hope so. I know I was running into issues with, because in the past I was just using like a vector 3 for direction, but I ran into a lot of issues. And so I definitely want to use quaternions like right away this time. So I think that's really all we need to do. Now it should work. Well, I still need to, I want to delete all of this first of all. Maybe I don't want to delete it yet. Maybe I'm just going to comment it out. Or, I guess it doesn't matter. We can delete this. We don't need any of this in here. We don't need to make this anymore. Inside of render, we don't need any of... Ooh, actually, we do need this. Oh, that's right. Never mind. We need to load in the chunk shader. But we don't need to do any of this. We don't need... We don't need this. We don't need to draw anything. Model, I guess we can put in here somewhere. Whoops. And we'll eventually put like add a position thing, but it doesn't really matter. What does the M stand for? That's shoot, wait, forget actually. Hungarian notation. I forget what it stands for now. I don't know. Oh, member, that's what it is. Yeah, member. My bad. Alright, so then in here we can do... Yes, we need to set the model. And like here we have to do like set map for model and set it to model. And then we bind the texture, we draw. Okay, so that should be good now. We don't need to do any of this stuff. We can get rid of this. We can get rid of this. And then we can load in a chunk. Okay, so then in here we can say chunk is equal to new chunk. And then I think I'm supposed to load or like actually give it chunk data. Yeah. So I guess we're also gonna need chunk data. Chunk data. Alright, so then we just, like we could literally just, hold on, make shared. Why did it do that? Pass in that should be good, I think. Oh, except we need to actually include all these things. Okay. Chunk.h. Okay, that should be good now. So now we should be able to do chunk data, chunk. Why is it called my app? Scuffed Minecraft. Scuffed Minecraft. That doesn't make any sense. Scuffed Minecraft app. Alright, there we go. That seems about right now. Okay, I think I kind of messed it up a little bit. Okay, let's just do chunk render. Alright, let's try it. Let's see. Do we get a face? Are you vertex pulling? He's vertex pushing each frame. I don't know what any of that means. I'm gonna be honest, guys. Why not unique pointer? Raw dogging pointers? You're right. I should be using a unique pointer. I just didn't feel like it. Alright, well, it's not there. So, hold on a second. Alright, fine. We'll use a unique pointer. I mean, I know that these are like safer and whatever. I don't really know what I'm doing. Or like, I don't know how much it affects performance. Whoa. Chunk data. Okay, chunk data doesn't seem to be working right now. Or not chunk data, chunks. We are generating the mesh. And then we are calling render, right? Am I an idiot? I might be an idiot. Pause, text pause. We have that there. Wait. I really am an idiot, huh? Rewrite it all in Vulkan, alright. Boop. Yippee. Yippee. Why is there nothing here? Brother. Or am I just facing away from it? What if I... Oh. It is possible that I'm just facing away from it. What if I make the north face too? Okay, so now we have the north face. No. Okay, so it's definitely just not working at all. There's nothing here. Nothing at all. So it's guessing what could be there and reducing the buffer size. I don't know what's going on, man. Alright, why are we not getting anything showing up? Zero, 2, 1, 1, 2, 3. Ask ChatGPT. Okay. It's not because I'm using GLM, right? We have our vertices, we're pushing that back. We have our indices, we're pushing that back. Data is returning just like the pointer to the chunk vertex data. And vertices is perfect. Wait, maybe I need to do... vertices dot size times size of chunk vertex. Let's try that. It might be that. I don't know. Ooh. Okay, so we're getting things to render now, but it's not quite right. Oh no. Okay, these are just 4 totally disconnected triangles right now. Okay, that's its size of data. Okay. Dot data is a pointer, so it won't work. Well, then what am I supposed to be doing? That's what I remember Minecraft looking like. Yeah, me too. That's exactly what I wanted to see. Dude, what am I doing? So size is the count of everything in there. And then we get the size of the chunk vertex. And then we get data. So that's just the vertex data. Oh boy. I have an idea. So let's look at an older version of Scuffed Minecraft. Let's see what I'm doing wrong here. Alright, very old version of Scuffed Minecraft. It actually does not contain anything at all. This is cool. Gosh darn it. Hold on. Never mind. I need an old version of Willow Fox. What am I doing wrong? Get checkout master. I gotta see what I'm doing wrong here. G1000. Oh, thank you. I can't read it. Yeah. So it's kind of annoying because Visual Studio doesn't work very well with CMake. So that's why I'm using VS Code. But yeah, Visual Studio is definitely better, like way better for C++. But its CMake integration is absolutely horrible. So that's why I'm using VS Code. Like, it works fine for simple CMake projects, but for anything even advanced as what I'm doing, it just won't work at all. Which is extremely annoying. Thank you for the bits, though. Okay, what? This is still wrong. Did I change this? I wanted to check out this maybe? I don't know. What is it doing? Oh, I'm just an idiot. Core, where's the actual code? Brother, why are you like this? You know, it's fine. I'm just gonna go to GitHub and do it that way. I gotta see why this isn't working. Alright, here we go. If we go to here and go to source and then index count plus equal to 4. Oh, wait. Oh, you're right. This is supposed to be vertex count, I guess, huh? Yeah. No, you're definitely, that's, yeah, 4 vertices, not 6. 6 indices, but not elements. Yep, that's, oh, okay. Well, I apparently have other issues besides that, but yes. Oh, no. Yeah, because then that'll be 4. Alright, I'm doing so many things wrong, probably. Am I buffering this correctly at the very least? Let me see. If I do... source, if we do world chunk, and then this is just getting the vertices. So the vertices are all like just about what I had. And then in here we set the mesh, and yeah, we're using data and size. Slightly better question mark. Yeah. Plus 1, 2, 3. Does that make sense? If we have 4, this is 0, 2, 1, 1, 2, 3. And then we increase this by 4. So then for these, this would be 4, 6, 5, 5, 6, 7. That makes sense. That's exactly what this was. Yeah. And then we're pushing back the vertices, and the vertices look right. So I feel like I might be passing data wrong. Pause this here. 0, 1, so we have the index right, 3 and 2, 3 and, oh, no, okay. Never mind, I figured it out. I had several issues, and that should be the issue that solves it now. There we go. Okay, that's better. Also, if I just want to see, so the south face is probably going to be on the other side, right? Or no, it shouldn't be. We should be facing north, I think. Well, this is not north, but yeah, okay, so that's right. So the south face is the one that's facing us when we start the program. All right, good stuff. So now we can make the rest of the cube. Now that we finally figured that out. It was a group effort. East face. And this is going to be like all of this. And then we get boom, boom. And then we do west face. I guess what I can do is like for all these faces, we could do like an inline void add indices, and then I can just do what, like int vertex count, and we can just push this into here. Oh, and then I also, I guess, need a city vector int indices and vertex count. And then for all of these, I can just put in add indices. And then theoretically, this shouldn't, like, this will just replace these in at build time, so it won't reduce performance at all. And that'll just make it a little bit cleaner. So then we have the east and west face. The west face is the other side. And then we reverse these. And then, of course, we can do the up face, which is like this, negative, positive, negative, positive. And then on this side, it's going to be like that. Yeah, and then we'll do the down face. Boop. And this just reverses these. Perfect. And then we buffer the data at the end. And now we should get our cube again. OpenGL buffer size and offset stuff is confusing. Yeah, I know, right? Look at that. We have a cube. Absolutely beautiful. Alright, it's perfect. So there's our trunk. Not really, it's just a cube. Okay, so first of all, a few things. This is a 3D trunk, so technically this needs to be trunk size times trunk size times trunk size. So this would be 4x4x4 blocks currently, and then I will, of course, change it later. We can get rid of that now. Alright, so our main class is good for right now. Actually, not really, because we need, when we create the chunk data, we need to actually set some of these things. All right, hold on a second. Let me do chunk data for int x equal to chunk size x less than chunks. Wait, whoops. X equals to 0. X plus plus. And we can do the same thing for y and z. Chunk data, shoot, dot set x, y, z to true. Okay. Chunk data, we can just add a little void set int x, int y, int z. What the heck? And then we can just do set. Ah, crap. It's going to be like z times chunk size plus y times chunk size plus x. Wait, what am I doing? Voxels is equal to value. And then we need to add a value. Okay, there we go. And then we can also do get. And I'll change these later because these suck. But this will allow us to get a chunk to render. Segmentation fault. Yeah, my first time trying, like, the Scuffed Minecraft in C++ that you see on my channel, that was my second attempt at it, because my first attempt was an absolute failure. It does have set. I just added it. Set. Avoid set. Alright, whatever. I'm sure it'll update eventually. Watching this pains me as I know the entire Minecraft Java code base. So seeing these implementations. Yeah, I'm sure it's pretty bad. Dude, what are you doing? Oh, never mind. I'm a little bit slow sometimes. Okay, so now that we have set, or now that we're setting the blocks, we can say, oh, we can go to chunk now, right? And then we can say for int x equal to chunk size. X is less than chunk size. I did it again. This is x equal to 0. I don't know why I keep doing that. I also have to figure, okay, so like I'm doing this wrong, by the way, because this shouldn't be x, y, z. This should be like, I kind of want y, or I don't know. I gotta see how I want to do this, but I don't want to do it this way. I know that. All right. Yeah, this is wrong. Oh, this is the wrong order. I don't remember what the right order is. Ooh. And I mean, that depends on how I implement everything. Technically, it's not wrong if I make it consistent. Okay. Get out of here. Sorry. But I don't like it doing. I think I want like X, Z, and then Y. What the heck? Because that way when we're iterating, well, this will help when generating chunks because we can just iterate upward a lot easier. Yeah, this is how I want to do it. And then I guess I'll just do the same thing here just to be consistent. Okay, there we go. Anyway, so moving on, we can create a cube for every single one of these now. So it's going to be a little bit different, of course. Because, oh, you've got to be kidding me. I have to add this to every single one. Guess what we gotta do now? What we get to do. Also, is this technically, hold on, let me look at my old code base again. Just real quick. I think in the past I was doing 0s and 1s. Triple nesting is so ugly, I know. You should make a class to create your voxel shapes like a bounding box class. That might be pretty good, actually. It might make life a little bit easier. The only thing is that, like, well, I don't know. Well, it might not make like a class. I might just do generate cube, maybe, and then have like booleans for each one. I don't know. Use middle click drag. Yeah, I should do that. Okay, so first of all, I want to replace every single one instance of this. Maybe I should replace the other one first. Nah, it's fine. With 0. Ooh, that is so ugly. And then every 0.5 will be replaced with a 1. And now the formatting is so bad. Oh, this is perfect. This is just exactly what I like to see. It's okay. At least now I can just delete stuff. And the reason for this is just because this is what I did in the past, and I feel like it's fine. Okay, let's... Could you format document? I feel like it's just going to mess it up. It's not... It doesn't do things the way that I want to do it. Alright, so this is just going to be like x plus y plus... I don't know why I'm doing it this way. X plus, and then y plus, and then z plus. Yeah. This is what we get to spend our time doing now. So we had x plus, y plus, z plus. I'm probably gonna abstract some of this out, like create like a helper function to make these cubes, so you don't have to worry too much. Actually, what I'm probably gonna do eventually, I don't know. Well, we'll see. We'll just do it this way for now, so we can get a working product, and then we can figure it out later. X, Y, Z. All right, perfect. And these plus zeros should be optimized out, so that shouldn't matter. It makes it look nicer, so I'm keeping it like that. All right. From your shape you create. Yeah, I'm thinking I might do like because I want to have things like stairs and everything. I might do like a voxel shape define thing, which you can easily define shapes. But I don't know yet. All right, there we go. So now we have 4 cubes, but of course, it's generating all these extra faces, which is not great. We don't want these. This is gonna lag out the game like crazy. So let's work on removing that. To do that, we of course need to get information about the surrounding blocks. So like for the south face, for example, we should say if... What is south again? South is like positive z. Yeah. So if chunk data dot get and we can do x, y, and then z plus 1. Then I guess this would just be not equal. Let me paste that in. Cool. And now we get to do this for every single face. Yippee. Oh, except we have to check if it's on the edge, because otherwise it's going to crash. That would not be good. Takes your builder out of the vertices. Yeah. So I do want to do like a voxel shape class or like a block shape. However, I do need to make sure that it's not adding in unnecessary faces, which I don't think would be that big of a deal, but it might make things a little bit more complicated. So that's why I'm not doing it right now. All right, so we have to say if z is, because this is a plus 1, right? So this should be if z is less than chunk size. And actually this might need to be if it's less than chunk size minus 1. Okay. And then we can kind of just copy and paste this here, except this one's going to be if it is greater than 0. Because the north face needs to check -1. Alright, let's try it with these. Okay. We clearly messed up the if statement. Excuse me. We clearly messed up the if statement a little bit. I think this needs to be an or, not an and. That's probably why. Do you always want to use triangles? Do you have some sort of DDA later? I don't know what a DDA is. I thought you had to use triangles, not gonna lie. I gave up when it came to adding my own block shapes. Yeah, C++ Minecraft was my first C++ project too. Besides some like stupid stuff in high school. Okay, let's see here. It gave me an error again. I'm realizing you guys can't see the error right now. There we go. Okay. For raycast. Okay. Raycasting. Raycast would be cool. Like ray tracing, shader, path tracing. That could be kind of neat. Okay, so. Oh, so is that gonna be what I need for raycasting? Yeah, I definitely need to do DDA for raycasting for like detecting when a user clicks a block or something. So I should definitely do that. Alright, so I did this wrong again still. I guess this needs to be is greater than 1. No. What am I doing wrong? I don't know, but one thing I did remember is that there should be X, Z, Y. I'm not sure if that matters here, but yeah, it's something I need to do. Okay, so if it is less than, does that need to be -2? Or did I do this the wrong way around? I might have done it the wrong way around. Yeah, I think you're right. It should be Z plus 1. Or Z, I don't know. It's something like that. Okay. What am I doing, dude? Z plus 1. So if Z is 0, because it checks if Z is less than chunk size. So then if Z, if I just do logger Z, where is it erroring out at? It's erroring at 0. Which means it's probably erroring out here. So if it is greater than 1, or I'm an idiot. If it is less than 1, and this should be great. I mixed these up. No? Or is this different? No, it's still wrong. What am I doing, dude? Wait, so if do one side at a time. Tell you what, let's see if north is working. So if Z plus 1 is greater than chunk size, or greater than or equal to chunk size, I guess, technically, right? Because then it'll get, so 0 plus 1, so if it's 3 would be the edge, because it's 0 to 3, so 3, 4 is equal to chunk size, so that would be something we don't want to do. Okay, well, it's still wrong. It's still failing at 0. Oh, wait. Yeah, why is it failing at 0? Z plus 1 Include the core package, and then we'll do logger index we'll put in this, and we'll put in size of voxels, I guess. Maybe that'll give us better stuff. What? Oh, whoops. Is chunk data initialized? It should be. That's not what I wanted. 4 out of 64. Why is it outside of the... What? So the index is 4. So I don't know what is going on. Return voxels. The memory should all be initialized. Hi, Anonymous the Real. How's it going? And we are passing the chunk data. Oh. Hold on a second. I figured it out. Chunk never actually stores a reference to it. Okay, there we go. Let me enable this again. Okay, so now if we look inside of here, the north faces and south faces apparently are being... Oh, no, I'm not rendering those. So the south or the north faces are now... One of the faces, some sort of faces are working. Is my point. I guess it's the north ones, eh? Or this? No, it's the south ones. I'm an idiot. It's fine. Okay, so now we can move on. Finally. So if this is less than 1 or the chunk data dot get. All right, let's try that. So now we should look in here and see. Yeah. All of these faces are correctly being, or not existing, are correctly non-existent. Perfect. So now we can follow this formula for the others. So for the east face, I guess we're going to need, yeah, positive. And this is going to be x plus 1. Then for west, it's going to be less than 1. And it's going to be minus 1. Copy this again for up. Now we can do x, or sorry, y. Y plus 1. Do the same thing for down. Less than 1, and we put minus 1 here. Not equal, minus. Okay. That should work. We'll see. Correctly non-existent. There we go, it's working. So now we can see we have all of these. Inside is blank. We have all the right faces, none of the wrong faces. Perfect. So that's done. Dude, I'm getting so many spam calls. What the heck? I got like 3 of them since the beginning of this live stream. It's crazy. Okay. Alright, so next up, or I guess now we can test this, right? So we need to do randomness, first of all. I don't know how to do that. C++ random. If we do, then we can do simple random. Int, sorry, bool, value, I guess, I don't know. Value is equal to rand 2. Then we can just do that, so that we don't have to create all these weird objects. Let's see. Okay, well, I don't think it worked. Also, I don't need to log this anymore. Alright, this should work now. Nope. Okay. Oh, I see what's happening. It's generating it even if it shouldn't. So if we just need to skip it if it's not. There we go. Continue. Okay, now we should be good. Name a space, Scuffed Minecraft. Yes. This is perfect. Look at that. Alright, we got chunks. They're doing chunk things. Is beautiful. Look at that. Alright, so now all of the unnecessary faces are being hidden, or I guess they're just never being made in the first place. And we can see everything. We can see the whole world. We can't interact with it yet, though. The whole world is a 4x4 block of randomness, but yeah. Okay. Woohoo! Now we need... This is the fun part, okay? Now we get to do multiple chunks. Okay. Chunk manager. Oh yeah, we can set the chunk size up to like 32 if we want. Then it'll be a big chunk. That's what our universe looked like 0.0001 seconds before it began. Whoa. Okay, look at that. We got big chunk. That's a lot of smiley faces. That's mildly terrifying, not gonna lie. It's a big smiley cube. Maybe I should make them dirt blocks now. This is the part that seg faulted for me. Understandable. Alright, let's do that. Let's make this a little cube or a dirt block. Copy the dirt into here. We're gonna do debug texture.png, and then this is gonna be our chunk texture. Okay, now we should get dirt. No. Oh no. Oh. I don't know what happened. Oh, this is not right at all. Okay, this is our dirt texture. What? Guys, I just put in this. It's called trunk texture. What did I do? Chunk texture. Did I spell it wrong? Looks good to me. Did I press run too early? What did I do? Why is it like this? Is it a weird file format? Or I mean, is it like a weird encoding issue or something? What's going on? Are the channels right? I don't know. Open with properties 7 color. Wait, indexed? Yeah, it's a weird file format. That's so annoying. Color mode. Yeah, it's okay. That should fix it. Looks like a color palette to me. Yeah, I guess that's what it was. Yeah, it's a color palette. It's not a texture. It's a color palette. I just tried to save it, but it didn't work, I guess. Yeah, set this to RGB color. Perfect. And if we open it up again, is it gonna work? Okay. I wonder if it's not working now because... Oh, wait, what if I just remove the assets folder? Okay. Now is it gonna work? It's indexed. It is indexed. No, why is it like this? Stop. Hold on, we'll just name this dirt and then we'll just create a new sprite. How about that? And then we'll just copy this, first of all. Okay. So now we'll call this chunk texture and we'll put it... That's not even in the right spot. Whatever. I gotta find that now. I gotta... Dude. What? Hold on. It didn't even export it right. No, why wouldn't you to export it? What? As a PNG. Okay. Now let's try it. There we go. Okay. We got dirt. Oh, it's yucky. Okay, we need to add like lighting. What is it? Okay, it's like a weird pattern, but I think that's probably just because of the random function that we used. I hope. Maybe. Yikes. It looks icky. Guys, this looks so gross. A sprite typically is Libre art or whatever. Libre sprite. Libre. I don't even know how you pronounce that. Alright, well, whatever. Anyway, it's working now. So let's go ahead and add multiple chunks now, okay? So we're going to have a chunk manager. Pragma once. We'll do namespace Scuffed Minecraft. Let me get rid of this. You've created the Farlands. Inferior texture. You're right. I'm going to get rid of the dirt garbage. Nah, we got to make it dirt. This is a classic, you know? Okay. What is this called? Class chunk manager. Alright, and then this is gonna need... This is gonna suck. Include... What is this called again? I forget. WV, that's what it's called. Include chunk. Alright, so we're gonna need an unordered map. What? I don't know why it's having a stroke right now, but that's okay. Using a vec3, or an ivec3, sorry. And a chunk. And it's going to be chunks. You need ambient occlusion. I know. I don't even know how to do that. Ambient occlusion. OpenGL. What is this? With SSAO. How difficult is it to implement this? I think we need like a whole rendering step for this. Is this just a post-processing effect? No. What am I looking at? We need to create like a whole texture. See, this is why I never did it. Because like, look at all this garbage. We need like a noise texture too, apparently. We need like all this garbage. Yeah, and then we need a shader for it. And then we need like whatever this is. Look at all this. This is what you have to do for ambient occlusion. It's crazy. It's multi-pass. I'll add it eventually. Guess I'm hard-coding lighting. Yeah. Oh, that's probably what I'll do. We can add some basic lighting if we want. I just have to look it up because I forgot how to do it. Let's see here. Lighting. Basic lighting. Here we go. If we do like ambient strength. And then we do diffuse lighting. That might look alright. Like if we did, instead of the fragment shader, we do some ambient lighting, some ambient strength. We do ambient strength times light color, which is just, okay. Well, if we do float ambient strength, I'm gonna set this to like 0.5, and then we do a vec3 light color, and it's just gonna be a vec3 of white. And then the object color is just going to come from the texture. Wait, no. What? Okay, hold on. Text color. Whoops. And we'll set that to this, and then for result, we just do a vec4 with our ambient times text color dot xyz, and then we just put in the alpha. And we put that in result. I guess there's not really much of a point in doing that. Actually, there might be. Yeah, never mind. We're gonna do it this way. Sorry. We're gonna do that, and then vec for result text color dot a. Okay, there we go. Because I think this is gonna be multiplied differently. And then we can do, there's no light direction. Yeah, I gotta add all that stuff. Ambient lighting, so that's our ambient lighting. And then diffuse lighting. Wait, I forgot that that's where we need normals. Shoot. So we'd have to add, yeah, this is gonna take a little bit longer, but that's okay. I'm alright with that. Because we're gonna need a normal. Might actually order this differently. Out vec3 normal. And then inside of our fragment shader, we can do that. And then for diffuse lighting, we can do vec3 light pause. And it's just gonna be, wait, not a position. Why would it be a position? We just want a light direction, I guess. Are you gonna do smooth lighting? Probably kind of both-ish, sort of. All right, light direction. I don't know what to put for this. We'll just do that for now, I guess. For now, well, for right now, we're not really doing much lighting at all. We're just doing some simple diffuse and, yeah, some diffuse and ambient lighting. We'll figure it out later. Wait, we want like a directional light. Yeah. So we have the lighter. Hold on, I'm trying to follow like this thing right here. Not 0. Okay, we'll do 1.0. We'll adjust it as needed. Choosing the right value. I don't really care. Just give me something. Dude, what are you doing? We don't need point lights. We just need this. Okay, so this right here is not what we want. Can I see the shader? That's all I really care about. Actually, you know what? I've already done this before. Let me just look at an old shader of mine. That might be easier. If I just go into shaders, chunk shader, chunk solid.frag, ambient strength, ambient color. Here, I'll just copy this. Ready? We'll do that. And then we'll do ambient directional calculate result. Boom. And then perfect. Okay, there we go. Now we have that, besides the fact that this is all... Oh, we don't have an object color. That doesn't make any sense. We don't need that. Okay. There we go. Now it should look good. Except for the fact that we don't have normals. It does not look good. I forgot. I forgot the normals. Still kind of looks better than it did before, though. Not gonna lie. All right, let's fix that. I'm also gonna need the code once again because I need to see the code. I need to see what these normal values are actually supposed to be. All right, so how to do this? So it goes normal for that. So we need pause, normal, and text pause. And we need, whoops, 1. This is 3, false, normal. Okay, so we have our vector attributes, and then for every single one of these, we get to do this garbage. Actually, I probably had this in the shader. Hold on a second. Whoops. Boop. Okay, and then -1. Copy this. This is gonna be mildly annoying. Okay, so we do 0. And then, oh man, I totally messed this up, didn't I? I did. East face, west face. I don't know if I'm doing any of this right. We're gonna have to experiment with this one. Up face is 1, and then I guess -1 maybe. Let's see here. That's wrong. Hold on, where's this? At 0, so liquid, otherwise, what is this? Is this south? No, this is north. So north is 0, so I think I mixed these up. Vertex normal and CPU is inverse normal matrix. Needs to be renormalized. I don't know, man. Okay, this looks... That's good enough. That's better than it was before. I don't know if I technically did this. I don't know if I have the normals right, but it looks like it has some shadows. So that's pretty much what I was going for. So we're good now. Alright, that's marginally better than it was before. So I am happy with that. Moving on, we can finally add more chunks. For the time being, I am going to turn this chunk size back down to 4. I'm actually gonna... Hold on a second. I gotta use the bathroom. I will be right back. Let me go... Oh. Alright, I'll be right back. I'm back. Okay. So back to what we were attempting to do before. Alright, let's do this. So we need to do multiple chunks. So we have the chunk manager right now, which contains our chunks. We can then make a... What the heck? Chunk constructor, destructor, and then we can do a render function. Perfect. And that's about it. I guess we can do like a... Well, yeah, it doesn't really matter. Alright, so we'll do this. Well, we'll add a lot more later, obviously. Whoops. Include chunk manager, namespace, Scuffed Minecraft, no inverse normal 3x3 matrix. I don't know what that is. Is that a rendering thing, I'm guessing? Cause I don't know a whole lot about rendering, if I'm being honest. Make the sender not have XYZ so you can tell the difference. Yeah. I'm not terribly happy with the shader, but I'll probably fix it off. Like, I'll probably learn on some stuff off stream and do that. Do it that way. Alright, chunk manager. So, for the time being, we are just gonna, there's not gonna be multi-threaded yet, it's not infinite worlds yet. We're just gonna create some chunks. So, world size. Yeah, I guess we're also gonna need max world X, max world Y, max world Z. And this will be in every dimension, I guess. Yeah, you're right. I need to do better. Like, I should really do normal calculations inside of somewhere, but yeah, technically, like, the mesh never rotates, so it shouldn't be a big deal, I don't think. I need it in entities, yeah. I'll figure normals out. I know I've done them before because I've done entities before in a test project, so it shouldn't be that bad. Alright, chunk manager. Int world size X is equal to 0. World size Y is equal to 0. 0 would be infinite. World size Z is equal to 0. Alright, so then in here, we can just set these. And world size Y, set that to world size Y, and then set world size Z correctly, of course. Alright, so then we create a new, well, for right now, we're just gonna do world size. Okay, so world, sorry, int x equal to 0, x less than world size x. And then we create our beautiful triple nested loop, because that's what we love to see, of course. Y. Alright, and then we can say, oh, and chunk is going to need like a chunk pause as well. Const glm ivec3 chunk ID. So then we're gonna need a chunk ID and a chunk position. I need to add this here. chunk ID, whoops. Set that to that, and then set chunk position to chunk ID times chunk size. There we go. Opening the second page of newest shader toy. Okay. Of n over 3, or yeah, n to the power of 3. Yeah, I think so. I don't know. Yeah, sounds about right. Okay. Okay, so then we just need to create chunks, I guess. So chunks dot in place std make shared chunk. Oh, we need a chunk. We need chunk and chunk data, I guess, huh? Yeah. Hold on. We need chunk. Okay, let's just make a new chunk data for now. Okay. So std shared pointer chunk data, and we'll just data is equal to make shared chunk data. And then we can just push back. What? Oh wait, I'm an idiot. XYZ is equal to data. Ooh, this needs to be shared pointer. What did this thing just do? Alright, there we go. So now that should work perfect. And then in here we can do chunks in place, make shared chunk. No, we'll just do auto chunk is equal to make shared chunk. Also, we can just make this an auto. Alright. So inside of here, we need to pass in the chunk data, and I guess we can do glm ivec3 id is equal to x, y, z, and then we can put an id here, here, and then we can do id is equal to chunk. There we go. As for this, we can do how does this work? It's like auto it is equal to, or no, I think we could just do for auto id chunk in chunks. Yeah, cool. Why store data in chunks manager? So I don't want to store it in chunks or in the chunk itself. I don't want the chunk object to have ownership over the chunk data, because the chunk might not, it's not necessarily going to be loaded in, because I guess, okay, so I should really separate this into chunk visual and chunk behavior kind of thing. Maybe the chunk, because like the visuals are the problem. Right now our chunk class really just handles visuals. Like a chunk render class. Maybe I should rename it to that. Yeah, make it more clear. Because like the chunks needs to have access to all of the chunk data around it. So that's kind of the main reason. And then also if we do like a client server sort of model, then the server, if it's a dedicated server, doesn't need to render it. Yeah, so I should do like chunk render, I guess. Should really be what I call this. That's gonna break everything, of course, but that's right. Alright, and then we can do that. Alright, so then inside of here, but then why is it stateful? What, the render? Alright, chunk manager. Alright, so then in here we can say chunk render. View ideally stateless, but then OpenGL is stateful. I don't know. I'm kind of like not on an optimization stage right now, so all of this stuff might be horrible. I'm just kind of trying to get it to work right now. Alright, let's see here. So, but like the chunk renderer doesn't need this. In fact, it shouldn't do this. This should be in the chunk manager. Because they all use the same shader and texture, so there's no reason to bind it every single time. They needed their own VAOs though, because it's basically like a mesh. There's a thread of sanity in that insanity. Yeah, I don't know what I'm doing. It's gonna store, it stores a reference to chunk data, but it doesn't have ownership. Oh, welcome back by a test. Yeah, so it doesn't have ownership. This is just so that it can generate the mesh. Because it's going to generate it over and over again whenever there's some sort of interaction, and this way we don't have to keep passing it down. Alright, so in here we don't need any of that. That can all go in here. Oh wait, that's not true though, because shoot, never mind. This needs reference to the shader. But not the texture. So then when we're rendering, we can just bind the texture, bind the shader. Boom. This you can do using namespace willowvox, so that I don't have to keep typing that. Alright, perfect. And then we can say, we don't need to keep binding the shader then, we could just set the model and then draw it. So then in here, we're getting the shader and the texture. We'll just label this load assets and then create chunks. And of course, this will eventually be in its own thread, so we'll get that done later. Alright, so we bind the texture, then we render each of the chunks. So then in here, we want to get the chunk manager, and then we want to do chunk manager. We don't need this anymore. Okay, perfect. All right, so then we are going to create a chunk manager. Shoot. Ah, man. Alright, in the chunk manager, we also need to generate the chunk data. CX, CZ, CY, I guess. CY, UICZ. Okay, chunk data. Create chunk data, and then after that we can create the chunk. I don't remember the last 10 minutes of this programming. I don't know why. It's a weird feeling. Okay, so that should be good, I guess. I don't really know. So then we render it, and there is here. So going back to main, then we don't need to create chunk data, of course. We need to create a chunk manager. We don't create this. Make unique. Perfect. And then inside of here, we can do chunk manager.render. I'm kind of scared to run this. Oh, okay. Well, it didn't work. Okay, there we go. Now it's got to do all this garbage. Hurry up. Load faster. C++ newbie question. When do you use unique versus shared? From my understanding, you use unique when you don't need it to exist in multiple places, as it kind of like shows ownership. And you use shared if like you're passing it around everywhere. What? Illegal expression. Chunk manager. Where is this at? Line 18. This isn't include. Oh, there's no hash. That's why. Forgot about that. Where did I have that? I wrote this before. Wait, what? No, it should have a hash, right? No, I guess not. Okay. We'll just do ivec3 hash.h, and then I can copy and paste my code from before. I'll eventually add that to the game engine. Okay, and then that way we can include this. ivec3 hash. What the heck? Alright, that should work now. Yippee, I don't see literally anything at all. Let's go. That's what I like to see. Wait, it's because no, it's because the world size is 0. Hold on. Okay, let's be a little bit more intelligent than that. If we do 1, 1, 1, then we should get a singular chunk, right? They didn't crash. Yes, look at that. Okay, so we got our chunk. We got one chunk. So now if we do 2 by 2 by 2, then it's gonna glitch out because I'm never passing, or I'm never changing the position of the chunk in the shader. So it's just a solid cube with a lot of cubes inside of it. Alright. let's fix that. That is going to be fixed inside a chunk renderer. Inside of render, we need to translate this by, what the heck? Chunk pause. Perfect. Define. Okay, so there's a hash for that. I might try that, see how that works. But there we go. We have more chunks next to chunks. Perfect. All right, let's see if I can do that easily without. So if I do this. I feel like I tried this in the past. That didn't work, but... Oh, would you look at that? It did work. Okay, so we have chunks next to other chunks now. Perfect. Temporarily, let's get rid of the randomness because it's hard to figure out our next issue. So we'll just set it to true for the time being. Alright, there we go. So we have our chunks next to other chunks. Each chunk is 4, by the way. Are you not? No, the chunk pause is already being multiplied by the chunk size. Alright, so now the problem is we have our cube, but the faces next to the other chunks are still showing. This is the part that's really annoying to solve because like the only way that I can really think of to solve this is to literally do like north chunk data and do that. And I hate doing that. It makes I really don't like that. But I can't really think of another way. Besides making, yeah, I don't know. So we're just gonna do it this way. East, west, up, down. I hate doing it this way. Okay. Especially since we need to do like void set north data to a shared pointer data, and we need to do this for every single one. You know, it's suspicious when everything works first try. I have done this a few times before, so okay, let's south, east, west, up, down. Wouldn't it be better to have a get block function or whatever in Chunk Manager? That is true. I could do that instead. It might be slower though, because it would need to get a yeah. That's the only thing is it's gonna be a lot slower, but it would be a lot nicer than this garbage. I love YouTube for not giving me a notification when you're live. Yeah, YouTube is a little dumb. My Discord server does notifications though. Well, I'll just do it this way for the time being because this is how I'm used to doing it. Okay, so that sets the chunk data, and then inside of here we need like sort of a nested if statement. Not really. Well, here's what we can do. I'll do south if this, else then south is equal to this. Perfect. All right, so this is kind of the structure that we're doing here. So it's if it's on the edge here, on the south edge, then we see if we have south data. And then if not, then south is just true. Gotta bounce. Alright, see ya, I'm Gyod. Alright, south is equal to true. Okay, so then we're just rendering the south face if all the tests, or yeah, if there's nothing next to it. But if there is, then we do south chunk data dot get xy0. Yeah, that should be good. Okay, this. So then we just do if south, right? I don't know if you can do this with a shared pointer, because it should just be like, I don't know if it's null pointer or what. I don't know how that works, but we'll see. So then in here, when we go to create the chunk, that's where it's gonna get weird. I guess we need to do create chunk data and then create chunk. And then we need to do chunk data for the ID. Ugh, I hate it. I hate everything about this. Alright, we're not gonna call generate mesh at the very beginning of this. Oops. Okay, so then chunk dot, well, okay, if x, well, we'll just do z, I guess, first. So if z, so the south face is going to be the positive one. So it's just going to be like if z plus 1 is less than chunk size, or sorry, no, m world size z. So that means that there's a chunk next to it. Then we do chunk dot set south data x y z plus 1. Oh, chunk data. Does that work? I don't know. This may or may not work. I don't know. No. Hold on. Where is this? This is a weird error. The variable south is being used without being defined. How is it not defined though? Runtime check failure, but it's literally not. We are defining it. Oh, never mind. My bad. Oh, and I did this wrong too. Oh well. So technically it's just not going to work at all right now. Okay. Now let's try this. So we are looking north, I think. So technically we'll see how this goes. So where are we? Okay, there, yeah, it's working. Cool. Okay. The south faces are being hidden. Woohoo! Alright, so our little template here works, so we could just keep doing this over and over again. Man, I don't like anything that is happening here. We're gonna do this so that it looks a little bit more organized. Alright, so we do north, and we kind of just copy this. But then we do if -1 is, well, if it is less than wait. Yeah, if this is less than 1, then if north chunk data south is equal to not chunk data dot, or sorry, north dot get xy chunk size -1. Okay, that should work, I think. I hope. This is where this stuff starts to get extremely not pleasant to look at. Okay, well, I guess it would help if I actually set the north data, huh? So then inside of chunk manager, we can kind of do this same thing, but we do if x is greater than 0, I guess. Set north data -1. Okay, there we go. So now north and south data, or yeah, north and south stuff is correct. So let's just set the rest of these real quick. So we get x +1 -1 and this is set east data, set west data, and then y, set up data, set down data. I did this wrong. Yeah, that seems about right. Oh wait, I didn't do anything here. And then we just do this over and over again, I guess. So we just copy this, put in our east stuff. We copy this, set this to 0. This should, whoops. East chunk data, east +1. Yeah. Alright, east should work now. I know it'd be a bit extra considering this is a game engine mostly, but will you consider using the method for meshes where you combine the faces on the same level? I'm hoping to. Are you talking about like since all these dirt blocks are together, like I could just combine the face of all of these? If so, I do hope to do that someday. I don't know how to begin to do that, but but yeah, I would like to do that. Okay, so then we do west face, and then kind of just do the same thing. West. Boop. And then this one is x less than 1. We do chunk size minus 1. And right here we could do chunk data minus 1. Yeah, that seems correct. Alright, let's check that. I saw it in a vid and thought it was absolutely amazing. Yeah, that it would be definitely very helpful. Ooh, okay. So that's kind of weird. Why is it doing that? What the heck? What am I looking at? What is it doing? Okay, let's try and figure out what I did wrong here. Oh, what? What am I doing? Oh no, I did it for this too. Hold on. I messed up a whole lot of stuff. Okay, that should be good now. It's pretty easy to do on one axis, depending on the implementation. Extremely expensive to do on 2. Okay. Okay, cool. That looks correct. Now we can do up and down. Okay. Up face. Boop and boop. Up. We can copy this if statement. We can get rid of this and do 0. We can do, what is it, x minus, or yeah, x plus 1, sorry. And then we can just copy this. Alright, and then we can do down face. Down, and then this one is going to be y less than 1. We're gonna do chunk size minus 1 and y minus 1 here. Copy this. Get rid of this. Perfect. Okay. Here we go. Now, moment of truth. There are no extra faces inside of this big old chunk of chunks. What are you doing differently this time? Why did you try to rewrite it? So, there's a few reasons. Mainly just that the code base was absolutely horrible and it's starting to get really annoying to work with. So I just decided to rewrite it. But I'm also changing the way that the game engine works, so it's more modular, and that requires a lot of rewrites as well. So I just figured I'd start from scratch. It'd be easier. Whoops. I feel like Visual Studio is better for C# or for C++ in general, but it doesn't work with CMake very well. Its CMake integration is awful, so that's why I use VS Code. Okay. Alright, so now we have working chunk stuff and chunk manager stuff, which is pretty cool. Let's go back to randomness so we can see it in action. Alright, so every fourth block, like these two are connected, seems to be working pretty well. Looks like everything looks like it's working on the chunk borders. It's a little bit hard to tell though. Like that's rendering, that's not rendering. This is a chunk border. Alright, perfect. Yes, alright. It's all working. Cool. So now we can change this a bit. chunk data, make our chunk size 32, and it'll still work. And then we'll get a big world. Perfect. Look at that. It's beautiful. I love the randomness being stupid at the top. It's great. All right. So that's our gigantic cube of dirt. Perfect. Okay, so we got like chunks. I'm going to actually commit this because it's been a while since I committed it. Beautiful. All right. Firelands would be like, yeah. All right, should we try to do infinite worlds? I'm gonna have a stroke. This is where we're gonna need threading, multi-threading. It's gonna be annoying. I'm trying to think. Okay, so this is doing multi-threading is gonna require a massive rewrite. Because I mean, massive rewrite is like I barely have any code to rewrite. But so for example, the chunk render, we have to call all of these OpenGL things on the main thread. And so that's gonna be annoying. Yeah, so all of these things will need to happen on the main thread. And in chunk manager, all of this stuff is gonna need to be moved over to a different thread. Yeah, which is fine. I might even want to do like a thread pool, you know? But we'll keep it simple for now. We'll keep it simple. I have so much random stuff open. Okay, so inside of here, so like chunk manager, first of all, is going to need to get like thread stuff, and then we are going to need to do thread full of threads and std thread chunk thread, and we're also going to need like a mutex for chunk data mutex and one for chunk render mutex. I'm also gonna need to like rename this. What? No, rename. Rename. Okay, there we go. I wonder stupidly if you can create an entire thread to greedy meshing. Well, I should be able to, because like what would be cool is if the chunk mesh generator is happening on a different thread. But that's kind of what I want a thread pool for. But yeah, we'll see how that goes. Okay, so with that, I had to think about how I want to do this. I guess what we'll do for now is we'll have a separate thread that runs periodically, pretty often, like maybe 10 times per second would be good. I don't know. We'll just do void chunk manager or chunk thread run. Yeah, whatever. Chunk thread. Sure. And then down here, we will define that. And then this is where we're going to just like, while, is a thread pool where a number of threads all take jobs out of the job queue? Yep. That's what it is, and that's what I'm thinking of doing. I guess we'll do chunk thread should stop while that, and then here we can say like chunk thread should stop is equal to true, and then we can do thread dot join, and then in here we can do like thread, wait, what is it, like thread, wait, what is it? It's like this thread sleep for 1 millisecond, roughly. Maybe even 5 milliseconds. I don't know. This will be better. Yeah. It'll be fine. Alright, so that'll just happen at the end of it. And then we need to create, okay, so we need to create like a chunk queue. That's the first step, right? We need a chunk queue, a chunk, map. Well, obviously we already have that. Let's see here. And then the queue can just be, we need to actually implement queue, huh? Or not implement, include it. I'm trying to think about how I want to do this. So, yeah, this is fine for now. So then the chunk manager, well, okay, for right now, because we're not doing infinite worlds and stuff like that yet, we don't need it to continuously add to the queue. We just need to create the queue at the beginning. So we'll do that. We're gonna say fill chunk queue, chunk queue dot on push XYZ. Perfect. And then that allows us to do to like go in here and just say like if chunk queue dot empty, if it's not empty, then we can start generating things. So auto front is equal to chunk queue dot front. So we get a reference to that. Well, I guess it's just an ID. And I think I want this to be for the renderer, right? Maybe. I don't know. This is where it gets complicated because like there's the difference between the chunk data and the chunk, but the chunk requires all of the surrounding data, or all the surrounding chunk data objects to be generated, and so we can't just generate this quick, So that's where this gets complicated. So if we do like I guess we want to create the chunk data for all of these first, right? Yeah, so then we create, okay, so here's what we're gonna do. We're gonna do create chunk data and then create chunk renderer. So we'll make shared, make the chunk renderer. We of course, yeah, we'll generate the mesh, and then technically this is generating the mesh data, not the mesh itself, right? I guess it doesn't matter. And then set that. And we also need like the chunk renderer mutex dot lock, and then dot unlock. Perfect. And then, so we have to create the chunk data first. Whoops. Okay. So chunk data is going to be easy enough. We just need to do create chunk data, set the data in here. We can of course do this, and this can be chunk data mutex, lock, unlock, and then so that creates that. So if we just get rid of this for the time being, and then we can just get rid of this because we don't have to do any of this anymore. So then in here, after we do this, we can say start chunk thread. So then, whoops, thread is equal to ban this spot. All right. I don't know how to do that, I'm gonna be honest. There we go, I did it. Okay. New, okay, what was it, like new thread? New, hold on, I forgot how to do this actually. C++ create thread. Okay, you just had to do this, I guess. Okay, so then we just add into the function chunk thread. Perfect. And then now that we have that, we can, well, I guess that's it. That's really all we have to do for that. So now inside a chunk, or chunk renderer, we can't do this here. Instead, inside of, and we also can't do this, we can't buffer the data here either. So instead, inside of render, this kind of where we have to do this. So create VAO if it doesn't exist. So then if not VAO, then we can do that. And then we can say we could put like a, well, okay, we're gonna have to do a few things. Oh, we don't need that. We need these two. And then we'll do dirty. Okay, so generate, or yeah, whatever, buffer data if dirty. And then here, we can pretty much just copy this code. The only thing is, we need this to be vertices. Ooh, no, we don't want that. Indices. Okay. One, two, three, 4, 5, 6. Okay, and then we can do this up here. Okay, and then now there should be no OpenGL code being called from the chunk thread. Let's see if it works. Okay. Use, oh, I need to use a reference, got it, okay. Does it work? No. More errors, yay! Do I need it to be like chunk manager, chunk thread like that maybe? No. What if I do a reference to that? Oh boy. What was I doing in here? Event bus. What? Chunk thread. What? Okay. I was doing this. Maybe that's what I'm maybe that's what I'm learning. Or doing wrong, missing. That's the word. Yeah, okay. Oh no. Ooh, that is trippy. I don't know if I like that very much. Oh. Is this leaking memory? Oh, it's definitely leaking memory. That's unfortunate. Alright. Oh, you know, it would help if I popped the chunk queue thing. Alright. I don't know why it was leaking memory though. Alright, now it's not leaking memory. That's good. And it generated everything. So that's also good. Let me turn the chunk size down again. You don't need it to be this large. It's also using 80% of my GPU. I don't know why that is. Okay, so now we have our chunks generated. That's cool. However, we're gonna have extra faces again. So we need to fix that. Yippee. Okay, so basically in here, what we need to do with our chunk queue, we need to generate all of the chunk data surrounding the chunk if it should be generated. Generate surrounding chunk data. If what is it? Hold on. If how do I chunk if it how do I check if it exists? C++, see if key exists in unordered map. If chunk data dot find ID is not equal to chunk data dot end. There, we do it like that. So then we generate the chunk data if it doesn't already exist, and then we go with the surrounding data. This is gonna really suck. What? Okay, I need to do shared pointer chunk data. Oh, whoops. Data is equal to chunk data. Oh, you know what? Whatever, it's fine. I don't care right now. We'll make this more. I'll make it more efficient off camera, off the stream. It's kind of like boring to do optimizations because I have to think about everything, or it's hard to do on stream because I have to think about everything. So we check if it exists, and then if not, we make it, and then we have to kind of do the same thing for all of this. So. GLM IVEC3. Why shared pointer instead of unique? That's a good question. I don't know. I just chose one. I don't know if it's technically the right thing to do. It's like other things are going to be using it, but this does have ownership, so I don't know. I have to see what's the best option, but I will think about that later. That's why I like using raw pointers. I don't have to worry about all this garbage. Next ID, and that's going to be equal to XYZ. Nope, we don't get that. We get ID.x, ID.y, ID.z. And then this would be like the south one, I guess, for right now. We'll do that. And then we can say world state should be somewhat centralized. Yeah. I hate, like, because of the fact that you want to remove the necessary faces between chunks, that makes everything so much more complicated. It'd be so much simpler if I could just not worry about it, but then it would lag a lot, because that's a lot of extra faces. Doesn't sound like it would be, but it is. Alright, it also looks ugly and weird. I mean, not that you're supposed to see it anyway, but whatever. All right, next ID. Let's see here. So then we can kind of do the same thing. Neighbor lookup is so annoying, yeah. Maybe I should do... Let's see here. With shared pointers, can I set it to null pointer? So what is this? This is south data. So then we can check to see if it exists. If find that, else if id.z is, what is it, less than world size. Wait, if id, no, that's not a z, that's an x. If world size plus z is, or plus 1 is less than this, yeah, that makes sense. So then we can create new data. And I just realized that we're never actually adding the data into this for some reason. Oh, that's why. Because I'm doing it down there. That's awful. So then in here we do this, and then we do next ID, and we do south data. Yeah, that should work, I guess. This is horrible. I'm gonna have to think about this for like 3 hours straight. But well, that's fine. All right, so then when we create the chunk render, we do chunk dot set south data to south data. Oh boy. Hold on. Let's make it easy on ourselves and not make it random. What does it mean to create a chunk renderer? We create an instance. Oh boy. Why did it make it smaller? Why did it do now? It just doesn't generate it at all. Awesome. This is just what I like to see. So we got south data, chunk data, chunk size, and then we set to true. Then we do that. Why doesn't it work? We're not using regular ID anywhere, right? We're using next ID. What? Does that make sense? If ID... Yeah... Seems weird. Yeah, I don't know what I'm doing, man. I'm just trying to make it function. Okay, so currently it in fact does not work at all. So that's cool. Okay. Great. I don't know what I'm doing. Okay. You know, it is working, sort of. This is also horrible. I might make this off stream so that I can think about it better. Because this does work, besides the fact that now chunks are generating between chunks or whatever. Yeah, whatever faces are generating between chunks. But if we do a set chunk data, south data, so it's not finding it, so we're setting it to this, and then we set south data here. Oh, that's why it's not working. Wait, that doesn't make any sense though. Okay, now it's... Yeah, that's working. Perfect. Let me put this back in, and we can try it again. Look at that. Okay, so now the south data gets generated, added, and that's perfect. Beautiful. Now we can do the same thing for everything else. So next we can do north data. North data, the next ID will be minus, and we can say is greater than 1. We do north data, make and then we can set north data to north data. Let's see if this works. Perfect. Look at that. All right. Now we can do the same thing for the rest of them, I guess. This is horrible, I know. We make it first, and then we improve it after. So this is going back to this again, which is annoying. If id.x set east data to east data, and then up here where we have this sort of thing, we can do this, and then we do west data, do that. This should be -1. This should be greater than 1. That looks about right. Let's just test this real quick. See if it's doing all right still. Yeah, it looks like it's doing all right. Cool. And then finally, we need the vertical ones. So, whoops. Up data. This is going to be using +1 there, and then we can copy and paste this into here and change that to a Y. That's a major copy paste code. Yes, it is. Cool. That seems good. Set up data. East. How did I mess that up? And then we can do down. Down data. And then this is going to be greater than 1. We do all of that. Set down data to down data. Okay. This is not the cleanest code right now, of course. Alright, and it doesn't quite work. I probably missed something here. Down data for up data. Ah, yeah. Your code is beautiful. Thanks. Alright, but there's no extra faces anymore. Look at that. It's working beautifully. And now, when we do a bigger world, like 10 by 10 by 10, it will generate itself nice and slowly, nice and perfectly and stuff. I don't know what I'm saying. Look at that. It's just going to generate itself. Doesn't totally break the main thread. It's kind of slow right now, but that's okay. It does not run each frame now. Well, technically it doesn't work on frames, but I don't know how much 5 milliseconds is. It's several times per second. Millisecond to FPS. No. It is like, hold on, if I put this about like 200 frame or 200 times per second. What was the sleep for? Just to prevent it from constantly running and using up 100% of your CPU. Because otherwise it's just gonna, like, the project would just constantly use 100% because it's going to run whenever it possibly can. So I figured might as well make it calm down a little bit. Alright, perfect. So now it works, which is neat. So we can go back to this, set this to like 3x3x3. Usually nothing has to run if everything in player view distance is loaded. Yeah, well, I mean, I can improve it later as well, because, like, yeah, it's not really done in the best way at the moment. But my style of programming is to make it work and then make it good, because it's a lot easier to plan out and optimize things when you already have a basis of how it works. So that's what these streams are for, because I can't do good code while streaming because I'm kind of trying to, I have like split attention, you know? And so I come up with an idea for a stream, write some usually pretty terrible code, and then after the stream, or like just in the days to come, I improve the code until it's good, and then I make the video. Which is exactly what I'm going to do here. Do you build mesh data each 5 milliseconds or something else? Yeah, pretty much. So like every time technically it's like it generates the mesh data and then it waits 5 milliseconds and then it does that again infinitely. So it's not great implementation. It's just like temporary quick little code to make sure it's not using up 100% of my CPU. So anyway, this code is horrible, but again, I made it functional. It works. It works quite well, actually. Chunk thread. And so off stream, I'm gonna make it better. I'm gonna optimize it. Probably do a little bit of extra stuff that wouldn't be very interesting to do on stream. Hopefully add ambient occlusion, depending on how hard it is to do that. I don't know. And I don't know, because I'm gonna have to add, because that's like a post-processing thing, but that also has a lot of stuff to it. So it might take a while, but I don't know. We'll see. All right. Well, anyway, I think I'm gonna leave it there though for today. And next time I might play around with building or like generating. Oh, you know what? Yeah, because I got to do like block types and a whole block registry. That's probably what the next stream will be. In the meantime, I will improve the rendering or like the mesh generation and the chunk manager. I'll probably add some extra nice features as well. Maybe ambient inclusion if I can figure that out. Some more abstractions that'll just make life a lot easier. Stuff like that. So I think I am going to leave it there though for today. So yeah, thank you all so much for watching the stream. And I will see you all next time. Can't wait for next stream. See ya. See ya, deleted handle. See ya, Geek Gazer. See ya, CubeYT. See ya, VFox. Bye bye. Alright, I'm gonna end it now.